Hello everyone, welcome to my YouTube channel. This is Filipino explaining. You have a problem on a pendulum. Here, a man enters a tall tower, needing to know its height. He notes that a long pendulum extends from the ceiling almost to the floor, and its period is 12.0 seconds. A have been asked to find how tall is the tower. Then B, if this pendulum is taken to the moon, where the free fall acceleration is 1.67 meters per second square, what is its period there? So here, for this question, you just have to know the formula that relates the period, length, and acceleration and this acceleration is due to gravity. Are we there? So for A solution, for a string pendulum, period T, remember it's a string pendulum, period T is given by 2 pi L over G. This L over G is under a square root. It's under a square root where T is the period, L is the length, is for length of the pendulum, then G is the acceleration due to gravity or gravitational acceleration due to gravity. So from the question you have been asked to find how tall is the tower. So we have to find L. So the first step is to make L the subject of the formula. So we square everything so that we get rid of the square root. So we square so that we have T squared is equals to 4 pi squared. Then this is L over G. Are we there? So to get rid of this G, we multiply both sides by G so that we have GT squared is equal to 4 pi squared L. This G goes with this G. Are we there? Making L the subject of the formula now, we divide both sides by 4 pi squared, so that we have L, this 4 pi squared goes with this 4 pi squared, so that we remain with L, which is equals to GT squared over 4 pi squared. After that we just do substitution. The gravitational acceleration on Earth is approximately 9.8 meters per second square. Then the period you have been given as 12.0 seconds. Then we substitute. So G is 9.80 meters per second square times T squared, 12 from the question. Have here 12.0 seconds, but we square 4 pi squared so that it gives us 35.7 meters. For A we are done. B, if this pendulum is taken to the moon where the free fall acceleration is 1.67 meters per second square, what is its period there? For B, the free fall acceleration or acceleration due to gravity is what has only changed. The only difference with question A is that for A, the gravitational acceleration or the acceleration due to gravity is 9.8 meters per second square, but for the moon, for question B, the acceleration due to gravity is 1.67 meters per second square. So the period T to the moon will be given as 2 pi L over G moon. Are we there? Remember, the period will change. The period will change due to the change in gravitational acceleration, but the length will remain. The length will remain, whether it's on Earth or moon or where, the length remains, but G changes. So when G changes, gravitational acceleration changes, automatically the period T will change, but the length will not change. Are we there? So the period T on the moon is equals to 2 pi times L over G under a square root. So we substitute in the values 2 pi times L. We have found it as 35.7 meters over gravitational acceleration on the moon 1.67 meters per second square. 1.67 meters per second square under a root. Are we there? So that we get 29.1 seconds, and that's the answer. We are done with part A and part B. Thank you very much. Thank you so much for watching. Let's continue learning physics and mathematics, but please don't forget to subscribe and leave a comment at the comment section. And I repeat again, kama kuna video labda kuna area ambayo inakuchanganya, ambayo ungetaka labda ni explain ama ni create, hebu niandikie pale kwa comment section video yenyewe, topic yenyewe ambayo inakusumbua, so that I can create the video. Vile vile unaweza suggest, you can recommend my teachings, venye nafundisha, labda kama kuna mahali ushikangi unaweza sema pia pale, so that you can improve the teaching and learning process that is going here on my channel. But please usisahau kusubscribe, pia unaweza share kwa yule unaweza ona inaweza msaidia. Asante sana, karibu.